Hey, do you know what time it is? That's right. It's time to finish the math course. We're going to be looking at our last topic, which is working with data. And so we have several different topics, and you can look at several of them at different moments. And so you can skip ahead. I have in the description of this video the points where each section starts and where each one ends. Yes, that's right. So working with data, we're going to be looking at a bunch of different figures. Data is basically information. It's spelled the same as data. Data refers to the plural. So usually we do have more than one piece of data, therefore we're usually saying data, and it's spelled the same. Okay, so we'll first be looking at median and the mode, as well as what central tendencies are, and we'll look over what each of those terms means. And then our second term is the mean, which is what we usually consider to be an average. That's another term you'll often hear. Thirdly, we'll look at range and outliers. Then we'll be discussing the effects of outliers, and as well as that, we'll conclude with choosing the best of those methods in different circumstances. So it's going to be very exciting. Hold on to your hats, fasten your seatbelts. Yes, that'll be right. I was trying to think of something related to a goat, but I ran out of analogies, sadly. Okay, so first off, this entire course looks at the idea of central tendency, that we are trying to find a gist, looking at a whole bunch of information, trying to find out what's the overall trend. So for example, let's look at class averages. We'll look at other people's marks, shall we? That's always exciting to find out what other people's marks are. Unless they're all higher than yours, then it's actually quite depressing. And so overall, if you want to know how a class did, like as a teacher, there are a number of different ways you can look at this. And so there is the median and the mode is what we'll look at first. So this is actually in the first chapter. They give you an example of the several test scores out of 10. So I'm not sure what theirs were, but I'll just make up 5 test scores here out of 10. Okay, so we had 2 out of 10. That was terrible. And the thing is, those 2 the person had right, they were guessing. God. Okay, so we have 2, 4, 6, 6, and then we had, our smart person who is studying and really brilliant. Either that or they broke into the teacher's answer key or their filing cabinet and got their answer key. They got 10 out of 10. I'm sorry, I'm in a very jocular mood today. Okay, so the median, we're going to look at the median. You may have heard that word median before. When we're talking about the roads, that there's often a median is like a barrier that is separating the 2 different ways so that cars, you don't go into oncoming traffic. And so just like the median is in the middle of the road, so too is the median going to be the middle figure. And so to find the median, it's kind of fun. You're just crossing off numbers. The first thing you have to do though is make sure that all the numbers are arranged from least to greatest. Because if they're all in a random order, you need to arrange them first. And you'll see why, okay? So we're going to just cross this off. So we'll cross off the 2, cross off the 10, cross off the 4, cross off the 6, and that leaves us with a 6 in the middle. So the median is simply the data that's in the middle of all the data. So the centermost number. So you may be wondering, what happens if we have an even number of numbers? In this case, it was odd, so it was very nice to just find that number. And so quite often, you'll have a case where there's an even number of figures. So let's go 2, 4, let's say someone else came. The exchange student came. They didn't really speak English very well, so they only got a 4 out of 10. So all the other numbers are going to be the same. Okay, so let's say we have 2, 4, 4, 6, 6, and 10. So let's cross them off again, shall we? Okay. No, you don't want to? Okay. Go have fun, play at the park. No. Okay, so we're crossing it off. And so now we have these 2 numbers in the middle. So the 4 and the 6 are going to have to meet in a cage and fight. And, well, not quite. Instead, we're going to be adding them up and finding out, dividing them by 2 and finding out what is in between. So with 4 and 6, if you watched your Sesame Street, you would know that 5 is in between there. You may have some other numbers that are further apart, or they might come out to be a decimal. In this particular case, you're going to just add them up, divide by 2. So 4 plus 6 is 10. Divide that by 2 is 5. So 5 would be the median. which is kind of interesting because 5 is not actually one of the numbers. No one had a 5 out of 10. But that is the central tendency. Central tendency is 5 here if you're using the median. Okay. Now if you had, let's say, the two middle numbers happen to be 4 and 7, then that would be 11 divided by 2, and 5.5 would be the median. So it's entirely possible to have a median with a decimal. And in fact, some of your initial numbers may be decimals in the first place, but in this case, to keep it simple, we're just using whole numbers. Okay, so that is the median. Another kind we're looking at in our first topic is the mode. So you may be used to doing video games and it's too tough, or you're against an opponent who's beating you all the time, so you want to cheat. So you're going to go into God mode, make yourself invincible, and then you'll defeat Tiger Woods every time at that golf, right? So the mode is what occurs the most often. So basically, you could think of it as like what mode or what setting happens the most, if that helps. Or you can just remember it. Back in the old days, we didn't use these mnemonic devices to try to remember things. So I'm going to use the same initial set of data, and we're going to find the mode for that. And then we'll play around and see how it can be different depending on if we're looking at the median or the mode. Okay. Here we go. Okay, so 2, 4, 6, 6, and 10 were our initial numbers. So the mode is simply the number that occurs the most often. So in this case, it's 6, isn't that right? So we count 6's, therefore our mode is 6. Yes, okay. So now if we had, let's say all our numbers were different. Let's say we had our scores were 2, 4, 6, and 10, and there were no multiples of the same score. In that case, there would be no mode. It's entirely possible if none of the numbers, none of the values occurs more than once, you have no mode. Or if they all occur identically, like if everyone occurred twice, there would be no mode. It's also possible, though, to have more than one mode. So let's say in this case that we had, let's actually go back to our second set here where we had the exchange student. So 2, 4, 4, 6, 6, and 10. Okay, so in this case, the values that occur the most often are both the 4 and the 6 out of 10 on their quiz. So in that case, I'm going to underline the 4's and circle the 6's. In this case, we have two different modes. Okay. Lovely. Okay, so it brings the question up, if you're trying to figure out overall how the class did, what is the better thing to look at? Is it better to look at the median, or is it better to look at the mode? You'll note in this particular case that we have, in this case, so 6 and 5. In this case, the mode is 4 and 6. So it's kind of similar. It's not really all that far apart. And so in this case, perhaps there's something else that we'd want to look at. In fact, I would recommend, if you're looking at the class average, that the mean would be a better assessment of this. And we'll see just why that's the case, and why when people say, what's the class average? Yes, medians and modes are a form of average, but the mean is what we like to see the most often. Okay, and that is spelled the same way as, stop being so mean to me. Okay, so we're going to look at the same data and we're going to find the mean of it. So I'll use the originals again. So 2, 4, 6, 6, and 10. This is topic 12.2 now, by the way. So to find the mean, what you have to do is add up all the values and then divide them by however many values there are. So we'll add up all these numbers, and because there are 5 of them, we'll divide that by 5. Okay? So 2 plus 4 plus 6 plus 6 is 18, plus 10 is 28. Okay, so we have 28 divided by 5. You can tell 28 divided by 5 is going, I didn't leave myself much room there. 28 divided by 5 will be a decimal number, if you know your 5 times tables. So we're going to subtract the 25 here, so it's going to be 5.6. Okay, I love doing some manual division there as well as multiplication. So 5.6 is the mean. So let's compare that with the mode and the median for the same numbers. So for that, our median for the original was 6 and the mode was 6 as well. And so you can argue that the mean does a better job of incorporating the outliers, what you could say would be the lowest or the highest. Because in this case, we happily crossed off our 2 here like it was nothing. And yet because now that 2 is included in the average, and the 10 is included in that average for that matter, we have these lower scores are actually going to be directly affecting the average. So it really is, in this case, I would argue the more precise way to get an assessment of how that class is doing. Because let's take another look at how just looking at the median or the mode could be inaccurate, okay? So let's say in this class, these are the superstars, okay? 2, 2, 2, either that or they had a negligent math teacher. Okay, so 2, 2, 2, 2, 2, and then we're going to go with 10. Oh, you know what? Let's actually go. Oh gosh, I dug myself into a hole here. Okay, you know what? Okay, we'll have a couple 2s, but then we'll have a bunch of other higher achievers. Okay, so we're gonna go with 7, 8, 8, 9, 10. Okay, and then I'm gonna add another 2 here. Okay, so take a look here. Take a look at these bad boys right there. Okay, so our mode is 2, right? Because there are 2 8s, but really we have 3 2s. So 2 is the mode. So if I asked, what's the class average? You could say, it's 2. If you looked at the median, in this case, okay, let's cross off some of these numbers. In this case, the median, I'll hold this up here so you can see it. Okay, median is, crossing this off, and we have 7 and 8 in the middle. So we have to find out what's between them. That'll be 7.5. Okay, hey, 7.5 is the median. So I could say, no, our class average isn't 2 out of 10. Our class average is 7.5 out of 10. In fact, I'm the greatest math teacher since Aristotle. That's how high that class average is. So that's very different. Now let's see, though, what the mean is of these numbers. Okay, so maybe I should have done the median last so the numbers weren't all crossed off. Okay, but we add them all up. So that'll be 6 plus 7 is 13, plus another 16 is 29. That takes us then to 38 and 48. Okay, so we have 48 divided by how many numbers? We have 8 numbers here. Oh, this turns out beautifully. So 48 divided by 8 is 6. So 6 is the mean. So take a look here. If we're picking out the central tendency, that is, and I'll just box this off from our other information, we have as a mode 2. Is 2 the most accurate central tendency? Probably not, because most of the people actually did much better than that, and you are basically making it look like, yeah, most people had 2. The median, to say 7.5, well, that's, that is very central. It is physically central, as we see, according to this, but really that totally seems to negate the fact that, yeah, 3 out of 8 did very, very poorly. 6 with the mean seems to be a little bit more central because it reflects the fact that those 3 did very badly, but it's not so weighted down by that it doesn't show the fact that the other bunch, the other 5, did quite a bit better. So you could make an argument for the others, maybe for median, probably not for mode. In some cases, as we saw in our earlier examples, they may actually come out to be the same, right? Like if everyone had the score of 7 out of 10, all 3 of those figures would be 7. But in this particular case, mean is most likely the best one to use. Okay, so speaking of outliers, speaking of numbers that are much higher or lower, we're going to be looking at the idea of range or outliers. And we're going to be looking at taking a break from the class averages. We're going to be looking at some hockey. And some of these numbers are given in the math textbook. And I don't have that right in front of me. I think the PDF is somewhere there, but the numbers may be a little inaccurate that I give you, but the purpose is still there. So there's a chart that you'll see in your textbook about the scoring leaders, the top 5 NHL scorers in the 1985-86 season. as well as the season 20 years after that. And so in 85-86, that was very notable because it was the single highest point total ever by a player, and it was Wayne Gretzky. And Gretzky had 215 points. And so the second highest by anyone who was not Gretzky, because he broke 200 a few times, was Mario Lemieux, who had 199. And he came in second this season, which was Lemieux's second in the NHL, but he didn't have that many yet. He had about 141 points. And then you also had Jari Kurri and Paul Coffey. I think Paul Coffey and then Jari Kurri, two of Gretzky's teammates, they also finished top 5 in scoring. So we're just going to give them, let's say, 137, 135. And then you had Mike Bossy of the New York Islanders. They were the big dynasty before the Edmonton Oilers. So by this point, they didn't win any more Stanley Cups, but he was still getting lots of points. So 128. So this term range, we're looking at, you may have heard of a range, you may have gone to an archery range before. And the term range actually means like how far something can go. You could look at the range of a radio signal, the range of a weapon that is fired a certain distance. And so the range basically means what is the spread between your smallest and your largest value. So in this case, so that is a difference. So we're going to subtract the smallest figure from the largest one. So in this case, to find the range of these scorers, and that is spelled same as like a range like your stove. So we're going to go 215 minus 128. Okay, which gives us, okay, I'm going to do this in my head. That gives us a difference of 87. Okay, so our range is 87. But what do you notice about these numbers? 87 seems like a huge range. But if you forget Gretzky's total for a moment, take a look at those others. It seems like that's really not much of a gap. Those 4 scores only have 13 points between them. So that is, this one up here, the extreme that is Gretzky's, is considered an outlier. So an outlier is a value in a set of data that is much larger or much smaller than the others. And so you won't always have an outlier. So let's take a look, for example, in these tests. To say that all 3 of these 2s would be outliers is not really true, because that's almost half the data right there. Likewise, to say that 10 is an outlier is not really accurate, because it's only 1 higher than the next one, which is only 1 higher than the ones before that. So you don't always have an outlier. In this case, though, because Gretzky's is 74 larger, it's actually over 50% larger than the person right behind him, you could definitely say that is an outlier. And it could be much less as well, right? And so in this particular case, you may want to eliminate the outlier. If we eliminate the outlier, we magically have erased Gretzky's records. And now we look at what is the new range. 141 minus 128 gives us a range of 13. So whether or not you want to include outliers really depends. And this takes us to 12.4. And so depending on what you're calculating, you may or may not want to include that. And so, for example, if you had, let's say on a test, you were doing class averages, and let's say everyone failed, but one person got 10 out of 10. It takes me back to grade 8 math again. Sorry, no, I'm not boasting. So yeah, you have one outlier. You may well want to consider that outlier, include that outlier in the mean, because yes, most people did poorly, but bump it up a little because of the one that counts. Now, there's another example to give you where you may not want to include the outlier. And it talks about a school that is selling t-shirts. And so in the first week they sell like 10, the next week they sell about 70, and then after that, for the next 6 weeks, they sell pretty much between 8 or 12 t-shirts. And so then they ask you, okay, they're going to sell for a 9th week. They want to sell t-shirts a little bit longer. How many t-shirts should they order? And so if you used a mean, that 1 week that has 70 would drastically bump up the overall average. And you would likely end up, because if we look at y, just to write some numbers here for you to look at. So let's say they were 12, 70, 8, 9, 12, 10, and come on, 2 more. 8 and 11 again. Okay, so you take a look here. These are the numbers of t-shirts they sold each week. Probably, when you think about it, the 70, it probably took them about a week to really get the word out, and then once it did, people all bought in the second week, and after that you had, a few who were interested. And so if you include the 70 in your mean, you're probably going to get a number much larger, well, you will get a number much larger than what is likely to happen, right? We're probably not expecting there to be a big surge after most people have already bought their shirts. So in that case, if you're looking for a rough estimate, probably best to omit that outlier before calculating the mean. Okay? So with 12.4, basically you get a bunch of practical situations and you're asked, oh, should you include this or not? What is the difference between when you include the outlier in your calculation and when you don't? You'll notice that the median is actually a figure here of central tendency that will do a nice job of avoiding that outlier, as will the mode, because if the outlier is not occurring often, it won't be the mode in all likelihood. The mean, though, the mean is the one that's going to be affected most likely by the outliers. Okay, and so as far as choosing the best method of central tendency, we're already at 12.5. That's remarkable. Moving at the speed of light here. It really depends. So we talked about like a class average, figures like that. If you're looking at, okay, what are our average sales over a year? The mean is a good figure that reflects both the highs and the lows. It's all factored in there. If we're looking at a vote, so we looked at how the mode can really be skewed. When we go back to our class average here, the mode kind of got a bad name, right? Like you're totally omitting the value of over half the data. But the mode is useful in voting and choices. So let's say, for example, it's the election. We look at which candidate, which party got the most votes. And so in that case, all those other votes in our first past the post system don't count. It's only whichever has the most. And so in that case, it's not like we're going to average, like how can you average different things that like different votes for different parties, right? Like 5 liberal votes, 5 conservative votes. Do those average out to become 5 Green Party votes? No, it's not really possible. So in a case like that, or like a popularity contest where they're saying, okay, what do we want to have as our spirit day? Do we want pajama day or do we want Viking helmet day? Ultimately, there's not really going to be an average. So it's not going to somehow become half Viking helmet day and half pajama day. You're ultimately going to look at the mode, which choice is the most popular. Okay, the median can be useful as far as if you're wanting to negate those outliers. And so, for example, if we're looking at if you wanted to just not bother eliminating the outlier and say, okay, what is like the average of a top scorer in the 85-86 NHL season, you could go ahead and cross off top, bottom. The median would be then 137, which is more of a figure of central tendency, and it eliminates the outliers for you. So they have a lot of good cases there where you have to judge and pick and determine which is the most useful to use. The mean, the mode, or the median. And that was perhaps mean to finish so quickly, but sadly, all good things must come to an end. And this is our last math lesson of the year. So please do email me, get in touch if you are having trouble with this, and I'll be happy to get into teacher mode to help you out. I'll be looking at having the quiz up by Friday next week, and that will give you a full week to finish up the course and to do that quiz. And that quiz is the final thing you have to worry about in your grade 7 math journey. I would like to thank you for all your diligence in working so hard. And if you haven't been working hard, well, hey, better start to play catch up. And I will talk to you later in other subjects videos. Okay, take care.